everybody, it's Mrs. Pound. As you know by now, I am not at school because I have a sick child, but I wanted to make sure that you are prepared for your test next week. So I have left some things for you to do. The first thing I want you to do, obviously, is watch this video, and I'm going to go through a few things on this sheet that I gave you the other day in class that says Physical Science Chapter 1.3 test questions at the top. So I want you to have this out, and I am going to go over these. I don't know if you have tried any of them yet, but this material will be on your test Tuesday. So if you still have questions for me, you can ask on Monday when you take part one of your test. Part one will be based on the Quizlet stuff and your notes. So make sure you also do Quizlet today while I am gone. So I want to take a look at just a few of these. Now, the first question, this second question, the third question, look in your notes for the answers to those. Those are definitely in your notes. I want to take a look at this question here. And it says, how many protons, neutrons, and electrons does cobalt 56 have? Okay, so remember with this notation, and this is also in your notes so you could go back and review or go back to my videos. The 56 on the top is the atomic mass. The 27 on the bottom is the atomic number. So given this information, you can figure out all of these things. Remember, the number of protons is equal to the atomic number, which is equal to 27 here. And the number of electrons is the same as the number of protons, which is 27 in a neutral atom. Now, the neutrons are the atomic mass minus the atomic number. So when we subtract those, 56 minus 27, you get, let's see, is that, I'll get my calculator out here. I'm a little tired. That's what I thought, 29. So the number of neutrons is 29. Okay, now for the next one, make sure you have your periodic table out. It says draw an atom of carbon to include all electrons in increasing energy levels. So the first thing we have to do is we have to find carbon, and it's right here. Now remember, the periods are the energy levels, so we know that carbon is going to have two energy levels, so we'll draw two circles around it. And the first energy level has two electrons, and you can remember because there's only two elements in the first one. And then we go over to carbon, and there will be 1, 2, 3, 4 electrons in the second energy level. And its atomic number is 6, so we know it's going to have a total of 6 electrons. So we have carbon here. Our first energy level always has 2 electrons. Our second energy level can take up to 8, but carbon has 6 electrons in it because its atomic number is 6. So we already have 2, so we need 4 more. 1, 2, 3, 4. So there you go. And it has 2 energy levels because it's in period 2. Now, let's draw an electron dot diagram for boron. So we look for boron here. It's right here. So we write the symbol for boron, which is just a B. And then we look at what group it's in. It's in group 3A. So group 3A, or it's also 13. Remember, in this group we have 3 valence electrons, and we just cross off the 1 here to get our 3 valence electrons. So 3 valence electrons, because it's in group 3A or group 13, whichever system you want to use. So then we just start going around putting our electrons, 1 on this side, 1 on this side, 1 here. We have our 3. Okay? Now the rest of the question says, will boron most likely form a negatively charged atom or a positively charged atom when it reacts with another atom? It has less than 4 electrons. It wants 8 in its valence shell to be happy. So if it has less than 4, it's going to give them up. So boron will lose its 3 electrons. Now, if it loses electrons, if it loses negative, it becomes positive, okay? So it will lose its 3 electrons and become a positively charged atom. Because it lost negative charge, and the positive charge from the protons in the nucleus will take over. Now, if it were to gain electrons, it would become negatively charged, and what would gain electrons would be something that has more than 4 valence electrons, would want to gain to get its 8, and then it would become negative. Now, calculate the atomic weight of an element given the mass numbers of percent abundances of its isotopes. This was in that extra worksheet that I told you to staple to your notes. So look there and review this. From your notes in that worksheet. And then finally, the 2 essay questions. This is information that's in your notes, so go ahead and find that from your notes. So what you should be doing for the rest of this time is looking for the answers to the rest of these questions, making sure you know where to find them, or writing it down to make it easier on test day, and studying on Quizlet. That's what you should be doing with your time that you have that I'm not there today. So have a good day, have a good weekend, and I'll see you next week. And if you have questions, feel free to ask me on Monday, or message me through Classroom, or even email me at sarahpound@bbcajamestown.com. Okay, so I'll see you Monday.